Hi everyone, welcome to week 12. We're going to continue talking about vectors that we started last time. So far, we have looked at a qualitative way of adding vectors. In fact, two ways of adding vectors, tail to tail and head to tail. These methods only give the diagram to the addition. They don't give us numbers, not the magnitude, not the angles. For tail to tail addition, we align the vectors such that their tails touch, and then we can complete the parallelogram and the diagonal is the sum. For head to tail, we align them so that the head is next to the tail. And when we do that, we complete the triangle to get the sum. Again, notice here that no matter which method you use, you end up with the same direction. So let's start with the simplest case, parallel vectors. Suppose vector A has a magnitude of 10 and an angle of or direction of 0 degrees. Vector B has magnitude 5 and an angle of 0 degrees too. Then, in the diagram, this is what it looks like. A plus B can be added directly, and it's just going to be this new long vector, which is A plus B, and it has a magnitude of 15 and a direction of 0 degrees as well. So this is the simplest case where the magnitudes can be added directly. Now let's look at an example with an application. One way to visualize addition of vectors is to use force on an object. For example, say a force of 10 Newton applies to a block. The Newton here, N, that's just a unit. It's a unit for force, which is just like kilograms or pounds and meters, etc. There's a block on a table. 10 Newton applies to the right, and another force of 5 Newton applies to the right. What's the total force on the block? It's pretty simple. It's like you and your friend pushing this block. The total force is 15 newtons, which means they just add up. That's what parallel vectors do. Now, similarly, now let's say you're pushing 10 newtons from to the right and your friend is pushing 5 newtons to the left. What happens to the total force in this case is going to be 5 newtons to the right because you're pushing strong with a more force than your friend. So the block is going to move to the right. So we're going to extend this to non-parallel vectors. The tool we use is recall. Any vector can be broken down into the components, the x component ax and the y component ay. This is what they look like. Any vector, you drop a perpendicular, you have ax, which is given by a cosine theta, and then you have ay, which is given by a sine theta. Now the strategy is, if a and b are two vectors, you break them down into x and y component, and you add the x component and the y component together. For example, if this is a, this is ax, this is b, this is bx, this is ay and by. If you add ax and bx, let's call that vector rx. And we can do that because these are parallel. Similarly, I add ay and by, and I call that vector ry. Let's look at an example for that. That same vector, we change the angles. Okay. So in this case, we're going to have to use the calculator. So let's see. To find rx and ry, I first need to find ax, which is going to be 10 cosine 45, which is 10 cosine 45. Making sure it's in degrees is 7.07. Ay is 10 sine 45, which is also 7.07. Bx is 5 cosine 60, which is 2.5. And by is 5 sine 60, which is 4.33. So by our definition, Rx means I add up Ax and Bx, which comes out to 9.57. And then Ry is I add up Ay and I add By, which is 7.07 plus 4.33, gives me 11.4. Let's look at another example. In this case, AX is going to be 7 cosine 130, which is negative 4.4, negative 4.5. AY is 7 sine 130, 7 sine 130, which is 5.36. BX is 11 cosine 230, which is negative 7.07. And BY is 11 sine 230, which is negative 8.43. So once again, Rx is going to be AX plus BX, which is, in this case, it's negative 4.45 minus 7.07. So it's negative 11.52, and Ry is AY plus BY, which is 5.36 minus 8.43, which is negative 3.07. Now, what does this mean? What do all these negative things mean? Let's draw them. See, where is A? 130 means it's in the second quadrant. That's where A is. 230 means it's in the third quadrant. Now, by what we have seen is that the resultant is both negative, so it's in the third quadrant. And indeed, when you complete the parallelogram, that's where you expect the sum to be. Right? Because this is Rx and this is Ry, and that's why they're both negative. In the next video, we learn how to find the angle of the resultant.